Today we're going to be doing another LeetCode problem. This one is called threesome. We're going to be solving it in C++ as always. Let's get into it. So we're given an integer array nums, and they want us to return all of the triplets such that their indices are not the same and their values sum up to 0. Now, note that the solution set cannot contain duplicate triplets, so that just means two triplets with the same values should not both be returned, or 3 or 4 or so forth. Only unique triplets, and they want the values of those triplets, not the indices. In twosome, they wanted the indices. In this problem, they want the values. So basically what that means is if you look through this input array, you can see that, for example, -1, 0, and 1 sum up to 0. So that's one triplet. Now 0, 1, and -1 also sum up to 0, but since those values are the same, we're not going to return that since we've already covered those values in a triplet. Additionally, there's another triplet here, so -1, -1, 2, you return that one as well. So that's it for that example. This example, as you can see, it is possible that there are no triplets. So the output vector here is empty because there's only 3 numbers here and they sum up to 2. Remember, we're looking for 3 numbers that sum to 0. So for this, we have 0, 0, 0. Even though all of those elements are the same, it does count as a triplet because their indices are different. So that's it for the example IO. Let's go ahead and get into the problem. So basically, the solution for this problem is very similar to the sorted version of twosome, in that we're going to be basically going off of a sorted version of the input vector to take advantage of no auxiliary space, and then also a 2-pointer approach for finding helping us find triplets. So the optimal approach is going to be, we're going to have an outer for loop, basically, where we're going to look through each element in nums, and then with using that element in the outer for loop, we're going to have an inner loop, or an inner loop, but not really a loop. It's going to be an inner 2-pointers to find the 2 other elements that, when summed to the outer loop element, give us 0. And the time complexity of that is going to be big O of n squared, because it's n log n for sorting the array, and then this algorithm, the algorithm itself, is going to be n squared, so it's going to supersede the sorting operation. So n squared, big O of n squared time, and the space is going to be constant, because we're not going to be using any additional data structures that scale with the input vector. So the first part of the solution is we're going to use a built-in sorting method to sort the input array. So we'll put the first iterator there in nums, and then the last iterator to sort that in increasing order. So now the array would be sorted in increasing order, and the next thing we'll do is I'm just going to declare a vector of integers for our result, and we have no idea what the size of result is going to be yet, so there's no point in allocating any space there. And for the outer for loop, we're basically just going to use a C-style for loop, and we're going to start from the 0 index and then loop until the second to last index, or technically third to last index, because and the reason being is because we're going to be searching for 2-pointers inside of here, and we don't want to go out of bounds. So that's why we're not going all the way to the end of the array. We're leaving 2 elements there for our 2 pointers. So that's the outer for loop. And then basically we don't want to have duplicate triplets. So to account for that, the first thing we want to do is basically see if we have 2 elements that are duplicate of each other. So we're going to compare the current element with the preceding element, and if those are the same, then we can just skip to avoid duplicate triplets. And then note that we're comparing with the previous element here, so that would be out of bounds when I equals 0. So to make sure we don't go out of bounds, we'll just say, well, I is greater than 0 there. And then these if statements are executed from left to right in C++, so it's important to put this before we do this. That way, because if this is not true, it will not check this, and that'll make sure we're not going out of bounds there. So the order there is important. So skipping duplicates there, and then the next thing we want to do is basically initialize our 2 pointers. So being that the array is sorted, we don't have to check elements before the current one, because we've already checked those. So the left pointer will just be the next index, so I plus 1, and then the right pointer will be the end of the array. So the final index there. So nums.size minus 1. And then basically we're going to, for a 2-pointer algorithm, we're going to loop while the left pointer is less than the right pointer. And the first thing we're going to do is check if our current 3 elements are a triplet. So and remember, a triplet is when those 3 elements add to 0. So so the first thing is we need to see what that sum is. So let's just make a variable for that and then add all of those elements together. So nums I plus nums I at the left index plus nums at the right index. And then that's going to be our current, the current sum of those elements. And the first, there's a couple conditions, right? It's like either we do have a triplet, or the sum is greater than 0, in which case we have to do stuff with our pointers, or the sum is less than 0, and we move our pointers accordingly. So so the first condition here, like, we'll just check and see if the sum is 0, and if it's 0, we know we have a triplet, so we can push that set of elements, or that those 3 elements. So it's really a vector, those vector of 3 elements to the result array. So that's going to be nums I, and nums left, and then nums right. So, and that's if we have a triplet. So we can't just stop there though, because if you think about it, there could potentially be, you could be at like -1, and then let's say you find your triplet here. There could be additional elements in this array that give another triplet for this value. And remember, with the outer for loop, we're not going to go back to this value ever. So we need to make sure we get all the triplets for this value. So we need to keep searching here. But before we keep searching, to keep searching, basically, it'd be as simple as just decrementing the right pointer and incrementing the left pointer to keep moving along. But we don't want to have duplicates. We gotta make sure we're not looking at duplicate elements or duplicate values first. So basically, while the pointers are not overlapping, we just want to skip through those duplicates or the duplicate elements. So while left is less than right, and while the value at the left index is equal to the value at the next element there, we want to skip that, so to avoid the duplicate. So this would be left plus plus. We just want to move that pointer along to skip that. We need to do the same thing for the right pointer, but remember, we're decrementing the right pointer. So instead of right +1, it would be right -1, because we want to check that next element we would be decrementing to. And then likewise, it would be right -. So that's just to skip those duplicates there, the duplicate values. And then this keeps those pointers moving, so we can keep searching. And then the next case is if the sum of those three elements does not equal 0, then we need to adjust our pointers so that we're trying to get our sum closer to 0. So else if our sum is less than 0, so if the current sum of those values is less than 0, we basically want to increase the sum. But how do we do that for a sorted array? Well, let's take an example here. Let's say, let's just use our so say we have 2 pointers, a left pointer here and a right pointer here, and say our target is 10. Now, these two numbers right now sum to 5, and that's smaller than 10. Well, how do we get a sum that's closer to 10? Well, for a sorted array, imagine we increment our left pointer. Now that's going to increase our sum, because 2 plus 4 is 6, and that's greater than 5, which was the previous sum. Likewise, if we wanted to decrease our sum, we would decrement the right pointer. So we'd go from 1, 4, which is 5, to 1, 3, which is 4. So hopefully that makes sense. So, again, when the sum is less than 0, we want to increase our sum. And to do that, we're just going to increment our left pointer. And then likewise, there's only one other condition here, which would be when sum is greater than 0, but I'm going to hard code it for clarity. When sum is greater than 0, we want to decrease the sum to get closer to that target value of 0. So we'll decrement our right pointer. So this is pretty much it for the algorithm. Of course, we need to return the result array, because we haven't done that yet. But let's just go ahead and run this to see if there are any bugs. So it doesn't look like it. So I'm just going to zoom out on this so we can see all the code. And then I'll submit this so we can see our percentages. So beats 75% for runtime, and then beats 94% for memory. So pretty decent. It is the optimal approach, so it is what you would expect here. So again, to reiterate on the time and space complexity, the time is going to be n squared, because this operation here is going to be big O of in log n time. But this is going to be superseded by this code block here, which is going to be n squared time, where n is the size of the nums array, because remember, we're iterating through every element in the nums array. So that's linear. And then inside of that linear for loop, we're going to have another linear for loop here, where we're using 2 pointers and inching them closer together to find those 2 other elements. So, and that's going to be for all of the elements, after the element in the outer for loop. So that does simplify to big O of n squared time. And then our space is going to be constant, because we're not using any extra data structures that scale with the nums array. So Hopefully this video helped you understand this problem better. If it did, please leave a like and subscribe if you want to see more of these videos. So thanks for stopping by, and I'll see you guys in the next LeetCode video.